Continuing our discussion with factoring, let's use our greatest common monomial factor to factor the following expressions. So once we factor this expression, the result will be of the form GCMF, whatever the GCMF is, times an expression. So let's start by finding the GCF of 3, 6, and 15. Think of a number that can divide 3, 6, and 15. So 3 will work. So 3 divided by 3 is 1. 6 divided by 3 is positive 2. Negative 15 divided by 3 is negative 5. Now, we cannot find any more common factor between 1, 2, and 5. So let's now move on to the variable. So we have x here, we have x here, and we have x here. So x is a common variable. Now we are going to get the x that has the lowest exponent. So this one is x raised to 1, x squared, x cubed. So I have to bring out the x that has the lowest exponent, x raised to 1. Now, my middle and last term has the y variable, but my first term has no y variable. Therefore, y is not a common factor. It means that 3x will now be our greatest common monomial factor. To find the other factor, I just have to bring down these numbers. So 1 plus 2 and then negative 5, and then just attach the variables that we have after we divide each of these terms by x. So it's like what we're doing is we're taking the original problem and we are dividing each of this by 3x. Now 3 divided by 3 is 1, that's why we have 1 here. Now x cubed divided by x is x squared. Remember that when you're dividing, you have to subtract exponents. So you will have here x squared. 6 divided by 3 is 2, that's why we have 2 here. Now x squared divided by x is x. I have a y here, so just bring down y. So I have xy here. And then negative 15 divided by 3 is negative 5. X divided by x is 1. Bring down your y squared. So I have y squared here. So this will now be the factors of 3x cubed plus 6x squared y minus 15xy squared. Now we don't really need to show this step. We can mentally divide by just subtracting exponents. So for example, when we bring out x here, x cubed will become x squared. You can just think of 3 minus 1. So x squared, so that's 2 minus 1, which is x raised to 1. And 1 minus 1 will be 0, so x raised to 0 is just 1. So there's no more x here. So that's one way of mentally dividing this expression by your GCF. So this will be our factors. Now, let's say we would like to check our answer. To check our answer, we are going to multiply the GCMF with the other expression. So 3x times x squared is 3x cubed. Remember that when you're multiplying monomial, you have to add exponents. 3x times 2xy. Multiply first your coefficients, 6. X times x is x squared. And then bring down the y. 3x times negative 5y squared. So 3 times negative 5 first is negative 15 x y squared. Now if you compare this, we got the original problem. So that's how we check our factors. So this will be our final answer. Alright, example number 2. Let's first find the GCF of 12 and 90. For some students, they can easily get the GCF of 12 and 90 to be 6. For some students, they can easily get the GCF of 12 and 90, and they will say it's equal to 6. Now, for some of us who can't figure out the GCF right away, we can just start by finding a prime number that can divide 12 and 90. So 2 will work. So 12 divided by 2 is 6. 90 divided by 2 is 45. Now we can still think of a prime number that can divide 6 and 45. 3 will work. 6 divided by 3 is 2. 45 divided by 3 is 15. Now 2 and 15 are already relatively prime, meaning we cannot find any more a common factor for 2 and 15. So if we get the product of 2 and 3, we'll get 6. So 6 is a GCF of 12 and 90. Now let's move on with our variable. I have a here and I have a here. Since we have the same exponent, we can just bring out a squared. I have b here and I have b here. So b is a common factor, but we have to bring out the b that has the lowest exponent. In this case, b raised to 1. Alright, I have a c here, but I don't have a c in my first term. Therefore, c is not a common factor. This expression here, 6a squared b, is our GCMF. Okay, so let's get the other factor. I just have to bring down 2 and then the positive 15. If we bring out a squared and b, we don't have any more a squared and b here. So we just have 2 here. Same thing as 12a squared b divided by the GCMF 6a squared b. So this will cancel out, b will cancel out, 12 divided by 6 is equal to 2. Now here, we brought out a squared, so we don't have any more a squared. B squared, we remove b, so we have b here. Now, we just have to bring down c. So this will be the factors. If you want to check, or if you want to verify why we have 15bc here, it's just dividing 90 a squared b squared c by 6a squared b. 90 divided by 6 is 15. A squared will cancel out. It's just equal to 1. B squared divided by b is b raised to 1. And then just bring out c. And that's why we have the 15bc here. Now, of course, do not forget to check your answer by multiplying your GCMF by the other factor. So 6a squared b times 2 is 12a squared b. 6a squared b times 15bc, it's 90 a squared. B times b is b squared c. We got the original expression. So we know that this answer is correct. For example number 3, think of a number that can divide 32, 8, and 56. Now again, for some students, we need to start with the smallest prime number, but for some students, they can easily get the GCF of 32, 8, and 56. So let's just start with the smallest prime number, 2. So 32 divided by 2 is 16. 8 divided by 2 is 4. 56 divided by 2 is 28. So we still have a common factor between these three numbers. Again, we can say 2. So 16 divided by 2 is 8. 4 divided by 2 is 2. 28 divided by 2 is 14. Again, we have here a common factor. Divide by 2 again. So I have here 4. Negative 2 divided by 2 is negative 1. 14 divided by 2 is 7. Now 4, negative 1, and 7, we don't have any more common factor. So 2 times 2 times 2 will give us 8. Now let's move on to the variable. M, and m. So I have m here. M is a common factor. Let's bring out the m that has the lowest exponent. M squared. N, and n. So we have n for each term. N is a common factor. So we have to bring out the n that has the lowest exponent. In this case, n raised to 1. So this will be our GCMF. Just bring down your numbers here. Now, if we remove m squared and n from this, we will have n squared. Removing m squared n here, it's just equal to 1. So 1 times negative 1 is just negative 1. Removing m squared from m cubed, we'll get m. Removing n from n squared is equal to n. So this will be our... For number 4, let's think of a prime number that can divide 16, 8, and 5. We don't have a common factor between 16, 8, and 5. Now let's look at our variable. I have a here, I have a here, but I don't have a here, so a is not a common factor. I have a b here, but there's no b here. We have a b here. So since the middle term is missing the variable b, b is not a common factor. C here, but this one has no c variable. So c is not a common factor. In this case, we cannot factor this given expression. So cannot be factored. It means that this is a prime polynomial. Prime polynomial means we cannot factor anymore the polynomial. So this one cannot be factored. It is considered as a prime polynomial.